Welcome to this puzzle session. Here is the problem. In a group of 2n plus 1 men, or people if you like, each person shoots the one closest to them. Then we want to show that at least one person survives. Now here, before we proceed, there is an assumption in this statement which I have not written. The assumption is as follows. We are assuming that to any person, there is a unique person that is closest to him. Meaning, the following type of situation does not arise. You have a person A, you have person B and C, and both of them are, let's say, 1 meter away from A, and everyone else is far away. So to A, there are two people who are closest to him, and hence A will get confused who to shoot. Right? It is also assumed that each person shoots at the same time. So there is some buzzer which, when is pressed, all of the people shoot simultaneously. So these assumptions have been made, and with those assumptions, we want to prove that at least one person survives. Okay, so two assumptions. One is that to any person there is a unique person closest to him, and the second one is that all the shootings are happening simultaneously. Okay. As usual, you are encouraged to pause the video before looking at what we are going to discuss. And with that, let us now move on. So with any such problem, what one should do is start with some small value of n. So with n equals 1, we have 3 people because 2n plus 1 becomes 3 when n equals 1. So what happens here? Let's see what happens here. So we have 3 people, A, B and C. Okay. Now among the 3 pairs of distances, there is this distance, there is that distance, and there is that distance. One of them is going to be the smallest. Right? So let's say the distance between A and B is the smallest among all the 3 distances. Note that you cannot have the situation where the distance between B and A is equal to the distance between B and C, because then B would get confused who to shoot. We made the assumption that there is a unique person amongst A and C that is closest to B. So let's say A and B have the smallest possible distance, and then the distance between B and C would be strictly greater than this distance. Similarly, the distance between A and C would be strictly greater than this distance. Right? Therefore, A will shoot B and B will shoot A. Now, since nobody is shooting C, C will survive. So when there are 3 people, meaning when n equals 1, at least one person survives. In fact, in this case, exactly one person survives. What about n equals 2? If n equals 2, 2n plus 1 is 5. So let's put 5 people. D and E maybe. And again, let's say A and B have the smallest possible distance among all distances. Maybe I'll join that with an edge. This is distance D. And D is the smallest possible distance amongst all the pairs. So there is this distance, that, there are a total of 10 such distances. And this is the smallest one. So by the previous, case, we see that B will shoot A and A will shoot B, because this distance, let's say, is going to be strictly greater than D, for the same reason that we are assuming there is a unique person closest to B. If the distance between B and D were smaller than D, then this wouldn't be anymore the smallest possible distance among all the possible 10 distances. And if this were equal to B, then B would have, if this distance were equal to D, then we would have 2 people, A and D, closest to B, and that would be a contradiction. Okay, so all in all, again, since this is the smallest distance, A will shoot B and B will shoot A. Fine. So they kill each other. And now we have these 3 people remaining. There are 2 possibilities. Either one of these 3 people will shoot outside this cloud, meaning they will shoot A or B, or not, meaning all of these 3 people shoot amongst each other. In the first case, we have these 3 people with at least one bullet going outside this cloud. So you have 3 targets, but only at most 2 bullets would land on a target, and hence at least one target will survive. And therefore, this case is favorable for us. We have already shown that at least one person will survive. In the other case, where they shoot amongst each other, this is as good as the previous problem where n were equal to 1, where we have already seen that at least one person again survives. Right? So once we solved the case n equals 1, using that case we have solved the case n equals 2, and by the same reasoning you can go to n equals 3 and so on. And the formal reasoning would be mathematical induction. You use the principle of mathematical induction, or equivalently the well ordering principle. You will be able to write a full proof. It's the same, ditto same reasoning. So with that, I want to end this lecture. As usual, like, comment, share, subscribe, and I will see you next time.